In this tutorial, we will demonstrate how to prepare a test strip for experimentation. Onterra's nanopores have to undergo a conditioning procedure to get them ready for use. Remove a fresh test strip from the box and peel off the protective film. Flush 200 microliters of startup buffer through each channel of the test strip, and use caution not to introduce a bubble. Thoroughly dry the test strip with a Kim wipe and insert it into the nano counter. When you insert the test strip, briefly turn on voltage to make sure there is some amount of conductance through the pore. Check that the baseline moves, even slightly, from its original position when you turn on voltage. If the baseline does not move, you may have an air bubble in your test strip. In this case, take it out and flush more buffer through each channel to push out the air bubble. In the strip ID field, enter the 5-character strip ID located on the handle of your test strip. Click Validate. When the box turns green, you're ready to go. Next, enter the buffer information. It is most important that you correctly enter the conductivity of the buffer, as this value is used by the software to calculate pore size. When you are ready, select the Pore Eval button. Make sure that it is set to a preconditioning eval. Start the eval. Pore evals provide important information about the health of your nanopore and are used throughout the startup process. At the pre-eval, pay attention only to the pore size metric. Onterra's nanopores are drilled to be between 25 to 50 nanometers, so as a general guideline, if your nanopore opens to larger than 50 nanometers out of the box, it is not good for use. In this case, mark it as failed and start over with a new strip. Our strip looks fine, so we can continue to use it. Next, click on the Condition button. Here, we are going to use voltage pulses to help wet and stabilize the nanopore. The software will apply voltage until the pore diameter reaches a stop size. Enter our max voltage. We recommend 10 volts. The stop size will be auto-filled based on your strip ID. Our QC procedures determine an approximate ideal size for each batch of pores, but each pore is unique and could stabilize anywhere in the 25 to 50 nanometer range. In some cases, your pore may be larger than the auto-filled stop size, even before conditioning. In this case, adjust the stop size to be 2 nanometers larger than the current pore size. Click Start Conditioning. The software is directing the nano counter to cycle through high voltage to wet and stabilize the pore until it reaches the stop size. When the stop size is reached, conditioning will stop. When conditioning finishes, close the conditioning window. Turn on voltage and observe the baseline current. You are looking for a flat, stable baseline. Our baseline looks stable, so we are done with conditioning. Now we are ready for a post-conditioning pore evaluation. Calibrate the current. Open the Pore Eval window and make sure that a post-conditioning eval is selected. Begin the eval. This will inform you if your nanopore is good to use or not. Look for the following passing parameters: pore size between 25 to 50 nanometers, resistance difference under 10%, LFNP between -55 to -80 decibels, current RMS less than 30 picoamps. If your nanopore fails for one or multiple of these parameters, mark it as failing. If it is less than 50 nanometers, you can repeat the conditioning procedure, increasing the stop size in 2 nanometer increments as we described previously. If it is 50 nanometers or larger, mark it as failing, discard the test strip, and repeat the startup procedure with a new one. This pore fits within passing parameters, so we will mark it as passing. It is now ready to be used in an experiment. Some pores may need more conditioning even after hitting the first stop size. At the end of conditioning, after turning on voltage, we can see that this pore is still unstable. If, after the first round of conditioning, your pore still looks unstable, return to the conditioning window. Continue the conditioning process, increasing the stop size in 2 nanometer increments. Check your baseline stability after each increment. Stop the conditioning process once you have achieved a stable baseline or if your pore size reaches 50 nanometers. If it is unstable throughout the 25 to 50 nanometer range, it is not a usable pore. In this case, the baseline stability has greatly improved. Next, we would move on to a post-conditioning eval, as we described previously, and then onto an experiment using this pore. For more details on Nanopore Startup, please consult our written Nanopore Startup document or contact support@ontera.bio.